Hello, I am Jacob and my partner is Fabiha, and today we'll be talking about maple and ash and their properties for MLB bats. Just to give you some background, prior to 2001, the homogeneous, largely popular ash bats were the choice of MLB players, but this all changed in 2001 when Barry Bonds famously used a maple bat to break the single season home run record. After 2001 and to 2008, fans and players started to notice that there was an increase in broken bats, so they decided to do something about it. And the MLB issued an investigation into this, a scientific investigation. And they put out a statement that basically said that maple bats must be made in a face grain fashion. If you look in this diagram down here, the face grain is when the grain of the wood, which is these little arteries of the wood, when that is perpendicular to the ball's travel coming in at 9 o'clock or 3 o'clock. And the ash must be made in an edge grain fashion, where the ball's travel is going to come in parallel to the grain. And in further experiment, in this experiment, where the objective was to determine a relationship between wood density and a strain to failure in the respective woods. So the experimenters chose a Charpy impact testing, and to give some background on Charpy, a traditional Charpy impact test is one where there is a hammer attached to a pendulum, and this hammer is set up at an initial height h away from a specimen being tested, and when the pendulum travels through breaking the specimen, it goes up to a final position and final height, h final, and with the kinematics equations and with geometry, you can use these to find out the energy dissipated on the specimen. So in this experiment, this traditional Charpy testing was used on maple and ash samples, cross sections, that were placed on these support brackets, and a Charpy hammer came through resembling a baseball traveling at high speeds, which would crush these specimens, and with this yielded some results for the strain to failure as a function of wood density for the ash and maple, but it also allowed an investigation into the difference between the edge grain versus the face grain and their impacts on each wood species. So some more on that. You can see here that the bat usually breaks along these edge grains for the maple samples. Here's an example of a radial slope of grain measurement, which is a big part of the experiment, where once the wood begins to break, it usually breaks at this angle SOG, slip of grain, which is some positive value above 0. So if you trace this artery, you can see that the wood would break along that grain. And for results.
And so after seeing the effect that it had on the specific grains, we can also see the specific relation between the strain of failure and also just the failure energy that was exerted and exhibited in the experiment. So on figure 5, which you can see on your left, you can see that the strain to failure exhibits a much steeper response with respect to the density in comparison to the slope of the ash data. And on the figure to the right, so on figure 6, you can also see that the failure energy for both of these woods and their impact surfaces after being impacted by the ball and bat reaction. So the specific combination of the mash and the about the maple and the ash, depicts the primary interest that the MLB has, because this combination is actually what is used on field for the bat versus ball impact. And we can see in figure 6 that the flatter slope of the ash data suggests that there is more of a durability for the ash bats because they're less sensitive to the wood density in comparison to the maple bats. It is also important to note that for the purpose of this experiment, the scientists decided to specifically focus on durability being defined as the relative bat versus ball impact speed, so the velocity, at a specific location along the axis of the bat. And so due to this, the greater the relative bat and or ball impact speed, the greater the bat durability, which we can see from the scatters in the graphs. And despite this, this trend of it being spattered is normal since it was wood testing, so it's not an unusual trend to see such scattered figures. Next, after these results, the scientists were able to conclude that the maple had a higher failure energy on the grain's face compared to its edge. Even though this was the case, once the maple had begun to fracture, which we can see in figure 8, the SOG influenced the direction of the crack propagation of the wood, which Jacob mentioned earlier on. And these propagations can actually create blunt or spear-like pieces depending on the impact of the bat and the ball, and also the velocity, etc. So therefore, after all of these results that were concluded, that were analyzed and concluded, the relationship that was determined by the scientists was that the density greater impacts the failure properties of the maple than the slope of grain. And we can see that this applies to which bat is better to be used on field, maple versus ash, for baseball games.